In this example, we're looking to maximize the amount of money we make at our business. And so let's take a look at some basic information we were given in the problem and then see where we're going to go with this. I think we're going to switch over and use our graphing calculator to help us finish this question, but let's start it right here. So it looks like we're go-kart track owners. How fun. Based on our current business model, I suppose, we have 380 people showing up every week to race, and that's when we charge $35. So that's sort of our baseline information. What we want to do is we want to change the price in order to possibly make more money. And so through some research, I guess we've done, we found out that every time we reduce the price by just $1, we get 20 more people. And so I want to figure out, well, how many times should I reduce the price then in order to maximize my revenue? Now you may think, well, why don't we just keep reducing the price, more and more people will show up, but then eventually we're not charging any money, and so tons of people could be showing up but they're not being charged much, so we're not going to make money. So it seems like there must be an ideal value to this. So we're going to use this basic equation to sort of model our problem right here. So the amount of money we make, the revenue, is simply going to be what we charge multiplied by how many people show up. So let's take a look at how these parentheses will look in our problem. So for our price parentheses, right now we're charging $35, but then what we want to do is we want to reduce the price, and we're going to try this time reducing it just by $1. So I'm going to say 35 minus 1, but I'm doing that X number of times. I might reduce it just once, I might reduce it 5 times, I don't know. So 35 minus 1x will be 1 parentheses. For our attendance parentheses, we've got 380 people showing up. And then what I know from my research is that every time I reduce that price, I get 20 additional people. So plus 20, but then again, that's depending on how many times I reduce the price. So there's going to be my equation. I'll throw y equals in there in front. There's going to be my equation that models this situation. Now I'm going to go ahead and graph this one just the way it is. I'm not going to multiply this out. Although if we did eventually multiply this out, we would see that at some point I'm going to be doing x times x, and that's where your x squared is coming from. So we do have a parabola. And more specifically, it would be a negative x squared. So I have a downwards opening parabola, meaning there should be a maximum to this. So at this point, I want to actually graph this on my calculator. I'll be able to get a more accurate answer on there. So let's switch over to the calculator, and then we'll come back to this and answer our question once we've used the calculator to find that maximum. So we've set up our equation for our go-kart problem to maximize our profit by hand, but now let's use our calculator to actually do the calculations for us and take a look at what this graph looks like. So the equation we set up, I'm in y equals, the equation we set up was 35 minus 1x. That was a $35 initial cost, but then we're going to decrease it by $1 a set number of times. That's what the x stands for. And then for my attendance parentheses, we said, well, there's 380 people that show up right now, but then every time I change that price, lower it by $1, I get 20 more people. So we're going to say plus 20 times x, because 20 more people show up each time I reduce the price. So there's going to be my equation, my parabola that's going to model the amount of money that I make. Now, if I were to graph right now, I probably wouldn't see much because this window, a 10 by 10 window, is not going to be very good. So let's go into our window and make some changes to my domain and range in this problem. X stood for the number of times I reduce the price. So I could choose at a minimum to reduce the price none at all and keep it just the same. So my X min would be 0. For my X max, I would want to think, well, what's the most number of times I could lower the price? Well, since I'm lowering it by $1 from $35, the most number of times I could lower the price was 35 times. After that, if I tried to lower it more, I would have a negative amount of money I'm charging, which would probably be really bad for business. I'll leave my Y scale the same, or my X scale the same. For my Y min and Y max, that's my revenue. So my minimum revenue could be $0. If I charge $0, I'm going to make $0 total. So again, that would be bad for business, but I could use that. For my Y max, I really don't have any idea, but here's the trick that I do. Right now, I charge $35. And right now, I get 380 people. So what I'm going to type in for Y max is my revenue right now. It's $35 times 380 people. Right now, I make a total of $13,300. So I want to maximize my money. So I want to make a little bit more than that. So I'm going to make that number a little bit higher. Maybe I'm going to try 15,000. My goal is, when I graph this, I want to be able to see the vertex, the maximum point of my parabola. So if I don't see that, or if it's hard to see, I can change that Y max number as needed. So let's try 15,000 and see if that's good enough. So let's hit graph,
and I should see this parabola. So actually it looks perfect. It's almost like I planned it that way. I can see that it hits right here at 0. We said after $35 reductions I wouldn't be charging anything, but I can see the maximum that I want to see. I can see that vertex. If I couldn't see that, I'd want to go back and make my Y max a little bit higher. So let's go ahead and actually calculate that maximum value. So to do that, again, hit second and trace to go into your calculate menu. You won't see vertex, but you will see min or max. So this time, because we're trying to maximize something, since we have an upside down parabola, an opening downwards parabola, select maximum this time. Okay, and they'll ask you 3 questions. They'll say left bound, right bound, and guess. So take your cursor and move that to the left of the vertex. Remember, don't try to get too close or you might miss it. So like I wouldn't want to go there because I can't really tell. But if I go over here, I can tell I'm clearly to the left of the vertex. So hit enter. Then they'll say move to the right, so move your cursor again somewhere to the right of the vertex. Over here should be fine, and press enter. And for guess, you can just press enter. You don't really need to guess very well. And your maximum value should pop up. Now remember, we talked about what to do if you see all the 9s or all the 0s. Round appropriately, so this vertex must be 8, 14, 580. So let's go ahead and go back to our problem and actually interpret what those numbers mean in this particular example.
Okay, so I've gone ahead and made a quick sketch of what we saw on the graphing calculator. I've set up my domain range, my x and y values, and I wrote down the maximum that we found, or the vertex that we found, 8, 14, 580. And so finally, let's just go ahead and interpret what those answers mean, because that vertex by itself is not the answer. So what that 8 represents is the number of cost reductions we did. Remember, that was back at the beginning. So what I've done is I've done 8 $1 reductions in price. So in other words, I've reduced the price by $8. And actually that was the answer to their question. They said, how can we maximize our revenue? Well, let's reduce the price 8 times by $1. They did not ask me for the actual maximum revenue, but that's what this number would represent. My maximum revenue, if I did that, would be $14,580. So just be careful what question they ask you. They may ask you to give either one of those answers or both of those answers. They may also say, what should you charge now? Well, if we were originally charging $35 and we've reduced the price $8, then 35 minus 8 would get me $27 that I'd be charging. So just be sure you read the question carefully and answer what they want to know.